How can I click through the next one?
If you just click on it now, it should be all right.
All right, thank you. So the replication crisis has called into question the way research is performed in many fields, including addiction research. Alarming rates of opioid misuse and opioid-related deaths in many countries, including Australia, necessitates rigorous research to develop treatments for opioid dependence and opioid alternatives. This begins at the preclinical stage with research using animal models of opioid addiction. Relatedly, consistently disappointing rates of successful translation from animal to clinical studies has led some to declare a translational research crisis. The replication and translational research crises likely have overlapping causes: presence of a publication bias, questionable research practices, and a high risk of bias, among others. Practices encouraging transparency, reproducibility, and thorough reporting have been suggested as solutions to some of these causes. We wanted to understand the extent to which animal models of addiction research already implement some of these protective strategies and where there remains room for improvement. We searched 4 databases for behavioural in vivo studies, published between 2019 and mid-2023, that studied opioid dependence, treatments, and opioid alternatives. 255 articles matched our criteria. 90% of articles were coded by 2 coders. Coders searched each article and any supplementary materials for mention of a particular study characteristic using key search terms, and skimmed any relevant sections of the report. Several of the characteristics that we searched for are considered essential reporting by the ARRIVE guidelines, that is the Animal Research Reporting of In Vivo Experiments guidelines. One such characteristic is the use of randomization. Randomization helps to balance confounders known and unknown. We found 48.6% of papers reported randomization, such as randomizing the rats tested to a control experimental group. Just an additional 6.7% reported another group allocation technique. This leaves 45% of studies that reported neither randomization nor an alternative method, making it unclear whether these studies employed an appropriate allocation method at all. Masking, also known as blinding of the experimenter or data analyst, reduces the chance of the researcher biasing the results. Just 36.1% mentioned masking or blinding, and an additional 1.6% included statements of non-implementation. This suggests that overall there is a high risk of bias in this literature due to a lack of masking. Worryingly, a lack of masking and randomization in several other preclinical fields is associated with larger effect sizes. This suggests possible inflation due to bias. Sample size blinding is associated with less p-hacking. Only about 5% of papers gave any justification for their sample size. The low levels of sample size calculations indicate studies in animal models of addiction research may be underpowered. This issue may be exacerbated by data exclusion, which has a particularly deleterious effect on research that typically uses small sample sizes, such as preclinical research. About 31% of papers reported that they excluded data, and an additional 3.1% stated no data were excluded, leaving ambiguity in this respect in the majority of papers. 6% of papers stated they excluded outlying data. Outlay exclusion may be of concern because what is considered outlying is not standardized in many fields, creating an opportunity for bias to be introduced as researchers may favor outlay definitions that lead to statistical significance. Lastly, while 19 papers reported compliance with the ARRIVE guidelines, only 1 paper mentioned all essential reporting aspects that we looked at. It should be noted, though, that several studies have found that meaningful compliance to reporting guidelines requires the proactive involvement of journals during the peer review process, highlighting the fact that solutions cannot rest on the shoulders of researchers alone. We also looked at rates of pre-registration and data sharing, practices that may also improve reproducibility. We found 0 instances of pre-registration, registered reports, and analysis script sharing. Data sharing was slightly more common, with 5.5% of papers stating that they shared their data. This reveals that proposed solutions to poor research reproducibility are not yet populated in this field. Our results show that there is significant room for improvement in animal models of opioid addiction in regards to its transparency, reproducibility, and reporting. This improvement needs to be incentivized by funders, universities, and journals so that researchers have the necessary tools to implement effective solutions. Compulsory reporting of certain research practices may be an appropriate first goal for animal models of opioid addiction. This approach may increase awareness about the importance of these research practices while leaving the decision-making in the hands of the researchers, who are undoubtedly the best place to solve field-specific obstacles. Thank you.
Okay, good. Yeah. Okay, so our next speaker is joining us online, Anthony Manyara, who will be speaking about minimum sample size in multi-stakeholder Delphi surveys, replicability of results and recommendations.
Yeah, thank you. Can you hear me?
Yeah, we can hear.
Okay, yeah. My name is Anthony Manyara. I'm a senior research associate at the University of Bristol and also a honorary research fellow at the University of Glasgow in the UK. So I'll be presenting on sample size in multi-stakeholder Delphi surveys, which is work we've recently published, specifically on the minimum sample size of replicability when the replicability of results stabilize. So Delphi surveys use the wisdom of crowds, which is the collective intelligence of a group of people is superior to individual wisdom. Formal sample size calculation is not perceived to be necessary, but the number and characteristics of participant needs to be carefully considered. And small Delphi sample sizes calls into question the validity and reliability of findings. There was no empirical research to justify the minimum sample size in Delphi surveys, so we aimed to use 3 multi-stakeholder Delphi surveys to investigate the effect of increasing the sample size on replicability of results and to assess whether the level of replicability of results differed with participant characteristics. So we used 3 Delphi surveys, 3 large Delphi surveys. 2 of these surveys were used to develop reporting guidelines for clinical trials, that is the Spirit Consort Surrogate, and the Consort for Psychological and Interventions, Consort SPY, and another one was a core outcome set for burn care. In total, we had a sample size of over 1,000, and the ratings on the Delphi surveys were on a Likert scale of 1 to 9. We used sampling with replacement to draw random subsamples from the participant dataset in each of the 3 surveys. For each subsample, the median value of the rated survey items was calculated and compared to the medians from the original full participant dataset. The median number of medians that were replicated was used to calculate the percentage replicability, and the interquartile range, the variability, the percentage variability. We defined high replicability as 80% of the medians being replicated and moderate replicability as 60 to 79% of the medians that were rated being replicated. To some of the results, here are the 3 data sets, and these are box plots showing the random subsamples on the x-axis, so as samples from 20 to 500, and on the y-axis is the number of medians that were replicated with each subsample. So you can see as you increase the sample, the medians that were replicated increased, and at a sample size of 60 to 80 in all the 3 data sets, 80% of the medians had been replicated. To subgroup analysis, which we did a number of them, but I'll just present one of the subgroup analysis, and this is on professional role. So looking at different stakeholder groups, researchers, methodologists, and clinicians, at a sample size between 20 and 30, there was a moderate replicability of the results that you would see from the full sample of these stakeholder groups. So in conclusion, a minimum sample of 60 to 80 participants in multi-stakeholder Delphi surveys provide a high level of replicability of results, that is 80%. And for individual stakeholder groups, a sample size of 20 to 30 rating all items may be sufficient. So this work was recently published in the Journal of Clinical Epidemiology, where we provide more results and more subgroup analysis. And in case of any questions or collaborations on Delphi surveys, there is my email and my X handle. Thank you.
Okay, we'll move on to our next speaker now. We have Andrew Vonasch, who's going to be talking about interpreting studies where the main finding replicates, but not the control conditions.
Thank you very much. Right, so I'm a social psychologist at the University of Canterbury in New Zealand, and I ran a replication study on some behavioral economics studies that were pretty influential in the field. So these were studies, over 500 citations. There were 4 different studies in the original paper using 3 different paradigms. So we replicated all 3 of those paradigms. And the essential finding is that there are situations, supposedly, in which people's preferences will reverse. And specifically in ways that people will prefer less to more, which seems irrational and interesting. So that's why I decided to run this project. So there's 2 parts of this paper, 2 parts of the hypothesis, the evaluability hypothesis. One is sort of obvious. It's the more is better effect. And that's the idea that you have 2 ice creams. These are the actual stimuli here. So this one has more ice cream in it than this one. So if you present these together, everyone should prefer this one, except people who hate ice cream. But if you present them separately, then this one has a lot of ice cream in a small cup. And so if you just see that, you might think that's a generous portion. Whereas this one is a lot of ice cream, but in a larger cup. So it looks small by comparison. And so the idea is that people will compare to the size of the cup in order to make judgments of how much the ice cream should be worth. And so we successfully replicated this in one of the parts of the study. So that's great news. We've got a less is better effect. People are willing to pay more for less ice cream. And we've got a more is better effect when the judgments are made together. So far, so good. But we also ran these other 2 replication studies using very similar paradigms, but different products. And what we found is that we successfully replicated the less is better effect again, which is the surprising one. So that seems like really strong evidence for this phenomenon. But we failed to replicate the control condition. So we didn't find the more is better effect in these paradigms. So let me give you a brief description of one of them. So one of them, you've got a gift, and it's either a scarf that's worth $45, so that's like expensive for a scarf, or you've got a coat that's $55. So it's objectively more money, but that's like a really cheap, probably crappy coat. And so what we think happens is people are probably interpreting the coat is actually a really bad gift. And so even when they're judging them together, they prefer the scarf. So what this shows is that the evidence in these experiments is not really showing what it should be showing. So is the less is better effect evidence of preference reversals? Maybe in study 2, but probably not in studies 1 and 4 with these different products. Is the less is better effect evidence of the evaluability hypothesis? Study 2 seems like a reasonable test of that, but the other 2 studies don't seem like an adequate test of that. And one of the things that we also noticed is there was a little bit of pushback from reviewers because we had slightly changed some of the, we had some exploratory dependent variables because they didn't include the control condition in one of their studies. So they operationalized generosity and willingness to pay as their key dependent variable. But then in their introduction and in their discussion, they talked about all of these other concepts. But then when we used these concepts in our study design, we got pushback on it. So there's tension between how people operationalize variables versus how they actually describe the implications of those variables and how this research is commonly cited in the literature. So what does it mean when the main finding replicates, but not the control condition? What it means is that the paradigm may be invalid and it may not be testing what it's designed to test. So yeah, that's it. Thank you.
Hi everyone, I'm Coralie, and today I want to talk to you about one of my PhD projects. So as we've been discussing in this session, science is going through a replication crisis. Certain empirical studies have been found to be irreplicable. This replication crisis may not be only applicable to empirical studies, but potentially also statistical method research. So there's been recent interest, for example, this paper, to look at whether simulation studies used for statistical methods research are replicable. So simulation studies are a very important tool for statisticians, as they allow them to evaluate, compare, and to test different statistical methods. So we can see these simulation studies as some sort of computational experiment. But as with any experiment, maybe simulation studies are also undertaking questionable research practices. So for example, statisticians may be reporting that their new method is performing better than existing methods, or they may forget to admit to test certain conditions where their method may fail. So this could be explained due to the pressures to publish positive findings, but also to the lack of reporting guidelines in simulation studies for methods research. So in 2019, this tutorial paper came out with a first step towards a more unified guideline to conduct a simulation study for statistical method research. The authors in this paper describe 4 main stages of a simulation study. We noticed that the reporting component was only limited to a few recommendations, when in reality we'd expect to see reporting embedded within every single stage of this planning, coding, and analysis. So to raise this, we proposed to expand on their recommendations for planning, coding, and analysis, resulting in 11 key simulation steps, part of a simulation study. And for each of these simulation steps, we propose a reporting item, which describes what is expected to be reported within a manuscript. So quickly for today, an example is for the second step of the planning phase, so what we call data generating mechanisms. The reporting item would describe all the processes used to generate the simulated data and reference any relevant method, model, or theory. But why do we need reporting items? Just reporting an item is not going to enhance the quality of the simulation study. We believe that reporting is an important stepping stone towards more reliable simulation studies. Because when we report one of these items and ensure transparency and complete reporting by providing clear expectations of what needs to be reported and where in the manuscript. And doing so, it provides a foundation for reproducibility. And indirectly, it helps the researcher conducting a simulation study to consider more about the design and the conduct. So in our project, we conducted a survey of 100 simulation studies in ecology and evolution. And for the time's sake today, here are some of the key results that we found in our survey. In green are the percentage of papers that reported the item described on the left. Our survey is comparable to 2 other surveys in medical journals and psychology journals, who also conducted a survey of 100 simulation studies. So overall, we can see that our results in our survey are comparable to these 2 other fields. To conclude for today, there is room for improvement in the reporting of simulation studies to enhance the reproducibility. And the next steps of my work, I plan to seek community consensus to build our proposed reporting items into a set of guidelines for simulation studies in ecology and evolution. And in doing so, I hope to initiate some ideas and discussions towards more reliable evaluation of statistical methods. And I'd like to thank my co-authors. And if you're interested in my work, our project, our survey, and our ideas got published recently, and I'll be really interested in discussing about it today.
Good morning. I want to share the results of this research project, which is part of my PhD. I'm doing my PhD at QUT. And actually, Adrian was a member of the panel about 2 weeks ago when I defended the results. So basically, the main motivation for this one is to study how data availability policies are working in the field of economics. We are aware that there is a replication and reproducibility crisis in science, and many journals have established data availability policies, encouraging authors to share methods, data, and codes. However, we also are aware that any researcher doesn't have any incentives to perform a full reproducibility study because it's not worthy for their time and for the career prospects. So that's why I asked myself if it's possible to judge the completeness of the reproducibility materials ex ante without doing the full reproducibility exercise itself. It will be like judging how easy it is to prepare a recipe without cooking the plate itself. So you have a book of recipes, you just browse, I can cook this. You have all the materials, I can cook this. Or something like that. So the main research goal is to develop a measurement instrument to evaluate the ex ante reproducibility of a paper using the materials provided by the researchers, and then study how some factors can explain differences in the level of reproducibility after the metric has been developed. The factors come from three groups: the paper itself, the research team features, and additional replication materials not included in the metric itself. So the corpus analyzes materials provided by researchers that have published papers in the Review of Economics and Statistics journal in the period 2010 and 2019. This journal adopted a data availability policy in 2010. So it covered like 10 years, a 10-year period. And these materials are stored in the Harvard Dataverse. I analyzed around 800 papers, but only 734 delivered at least one file. So around 60-something didn't deliver anything, although most of them were at the earlier part of the observed period. In this stage of my research, I decided not to include any data and codes. Why not? Data, because it's not always delivered. Some researchers use confidential data, so they are not able to share the data with the readers. And for the code, it depends on the script language used. In economics, many researchers use Stata or R, but it's not compulsory to use any of those languages, so they can have the freedom to use any one they want. So that's why it's not a good idea to analyze the code itself at this stage. It's easier to analyze the README files because it's written using natural language, and the idea is to compare the README files against a benchmark or a gold standard that contains some components that should be there to perform the full reproducibility exercise. The benchmark is inspired by a similar one suggested by the American Economic Review, although I have excluded some components and I have added some on my own. There are 7 components in this metric. This table presents like an example. I will not go through all of that. I will just list the components, identifying the paper, identifying the data sets, the data sources, providing a good code book, providing the software needed to complete the replication exercise, instructions, how to run the code and use the data, and finally, which results can be reproduced using this information. The metric itself is really easy one. It's a weighted sum. The weights can be established or defined by the replicator. In this paper or in this research, I just use equal weights, equal to 1, and an indicator function that is equal to 1 if the component is there and 0 otherwise. The component itself is evaluated against, as I said before, some keywords. Some are static, meaning that they work for all papers, irrespective of the material in the paper itself. For example, using phrases as data repository or data description. Some are dynamic, meaning that they are based on the paper itself. For example, the name of a file, a data file or a code file that was delivered by the researchers. So I run after doing the whole exercise with like assigning a metric for all the README files in the corpus. I run some ordinal logic models to establish if these factors influence differences in the levels. I couldn't find any research teams factors that are statistically significant, but other reproducibility materials, such as the number of files delivered or some features of the code, for example, how many comment lines or the comment density with respect to the total number of lines, all of them are statistically significant and they are positively associated with the quality of the README files. I also run a model testing how time affects the quality of these materials. I use the serial issue of the paper as a proxy for time. And this was also found to be statistically significant, meaning that the quality of the materials have improved over time. Maybe it's because basically researchers learn, they can check what other researchers have provided in the past materials, so they can develop better materials when it's their time to share the materials with the journal. In the future, I want to improve the quality of the instrument. For example, I want to perform an intercoder reliability exercise with human coders with a subsample of the README files. I also want to establish the possibility of developing an structured measurement approach using artificial intelligence tools. And of course, it has to be required to incorporate information from the data and the code files, because at this stage, I'm only evaluating the README files themselves, as I explained before. And I also want to improve the econometric model because there is a possibility of the existence of nonlinear effects. For example, the research team size or the number of files. If the team deliver only a few files, maybe it's really easy to complete the reproducibility exercise. But for example, in some case, one paper delivered like more than 100,000 files. So maybe it's quite tricky to complete the exercise with such a big amount of files. I also want to address the fact that some authors have participated in more than one paper in the corpus. So that means that not all observations are independent. So that is also have to be addressed in the future. That's it. Thank you.